So far, whatever we were focusing on in the previous session yesterday was all about your bioeconomy, and this morning we were covering what is production and processing aspects. Yeah. So quickly, what is basically a processing aspect for fish? It's pretty much straightforward. Main focus is on harvesting, preserving at farm, yeah, that is cold water and refrigeration and freezing, washing, and then product is ready for consumption, that is again at the domestic level, yeah. And some of the commercial products are formed, and different products and different applications or different sources, that is source for animal feed, fertilizer, and what else was there? Animal feed, fertilizer plus food, yeah. And then whatever side streams are left over, they are used for making again high value ingredients. Many of you are doing topics somewhat related to that, yeah. So within within this, we also saw the biorefinery for seaweeds. That means how those seaweeds can be used for different functionality, different application. So one thing which was was not covered was related to microalgae. So do you think we can, whatever waste is generated, the liquid part of the waste, can that be used for the production of seaweed or microalgae? Yeah. How can we grow seaweeds? If doesn't need any water, can it grow on wastewater then? Or how many of you know about microalgae? Cholera vulgaris, spirulina. Have you heard of spirulina? That is some places called as a superfood, yeah. So one of the aspect here is related to your microalgae, yeah. And with after this microalgae utilization, you will see how we go back to your how we can use the waste stream to grow microalgae. So it will be one step forward and then one step backward, yeah. So you will have to prepare an assignment, which we'll talk about that at the end of this particular lecture. So if you see microalgae, yeah, which is quite similar to macroalgae in terms of application, but is having lot more functions. So one is animal feed, pharmaceutical, nutraceutical application, your pesticides, biopesticides and other environmental chemicals, cosmetics and healthcare product, and textiles and industry applications like natural dye. Can you name any microalgae? Cholera vulgaris, yeah. Cholera vulgaris, spirulina, any other? Porphyridium. So these are all colored microalgae, yeah. They are colored because of phycocyanin. Phyco means color, cyanin means containing compounds, yeah. So they can impart color into the product. If you take a microalgae, add it to the milk, whosoever is fortifying it with vitamins of milk product, so you can have number of different colored milk product, yeah. Once you have colored milk product, then if you make a cheese out of it, then you will get a colored cheese, yeah. So why to have always white color paneer or white color cheese? So you will have a color, so you get both the functional properties of microalgae plus the protein from dairy, yeah. So there are a lot of different applications. You must be wondering what this microalgae is doing in quantification of waste and mapping the waste from aquatic food chain, yeah. So this is also one of the important biomass which is produced or which can be produced by using your wastewater. Yeah. So how these microalgae are grown? How do you grow these microalgae? So normally these microalgae, they needs an input of again same as whatever is required by plants. Yeah, CO2, nitrogen, fertilizer, all those nutrients plus optimum condition. Yeah, so there are plenty of different species which can be produced, and applications are very similar to macroalgae. Yeah. So we have, as I mentioned in the morning, we have a dedicated one for both macro and microalgae cultivation. And once you have a microalgae, one of the issue with the microalgae is amount of solid coming in liquid is not very high. Maximum you can get 2 grams solid per liter of water or so, or in some cases you can go up to 3 grams. So that means a lot of, like whole the green water. If you keep a water in sun, you'll see slowly it becomes green. Yeah. If you have water tank, it becomes green. It's just because of microalgae production. Yeah. That's why you try to close it with, you don't want to give access to the sunlight. Yeah. And that microalgae is basically what is now being used for the food purposes or for different applications. Yeah. And type of species you grow. So one of the aspect is you select those species growing on a wastewater, and then to cultivate that species and valorize the wastewater by growing microalgae. Yeah, that's why these things are very important. And in science, observation is very important rather than knowing about things alone. Yeah, if you observe what is happening, and then you can make it to your advantage. So if you'll see different application now. You saw the biorefinery approach for macroalgae, starting from production in the sea, or that macroalgae can also be done in fresh water. Similarly, in microalgae, if you select a strain on whatever wastewater it is growing or it can grow, suppose your objective is to absorb more of the CO2 from the environment or to absorb some of the nitrogen fertilizer, huge number of database or number of species are already there which can grow on different types of conditions. Whether it is less of nutrient, salt or pH. For example, you have whey liquid, whey is acidic, so you can still grow a microalgae on whey, but you have to select a strain which can grow on salt or at lower pH. Those who can retain a temperature or light stress, so whatever nutrients are required, and this is very well documented how you grow on different types of water. So the advantage here is if you grow it on a wastewater, so you can valorize the wastewater to recover the inorganic nutrient in a form nitrate, phosphate and potassium, and convert into organic form in a form of protein. So if you have a nitrate, NO2 or NO3 in a water, yeah, how this can be converted into proteins? By what process? That is again the plants. Plants, they absorb nutrient from nitrate, nitrites, and this is also a wastewater. Yeah. So that way you can convert into different nutrient. And once it is grown fully, you have to go for harvesting method, that is either by when you centrifuge it, you get all the cells accumulated at the bottom, yeah, and then water can be purified to certain stage, or use a flocculating agent, whatever you use it for your wastewater treatment, to see how we can precipitate the cells, and then recover those cells will become a microalgal cells. Yeah, it's very similar how we use it for any other process. Even when you are extracting a protein, you solubilize the protein in alkali, and then you precipitate the protein by using acid, by using isoelectric precipitation, and then you can go for extraction, cleaning, bioactivity and other quantification, whatever you have to do. Yeah, and then based on the species, you have application for oil, protein, carbohydrate, vitamins, pigments and all those phenolics, biomass and everything. So this is complete biorefinery process. Whether you use a fresh water for specific purpose is the same way how the spirulina, cholera vulgaris, cholera sorkina, then you have Purium porphyridium. There are a number of different species are there which can be grown, and I will go into the details of different species when we go for microalgal production or how we can best valorize it. Yeah. So this was one of those project which was between Interreg Atlantic area, that is Ireland and the west coast of UK, west coast of France and west coast of Spain. So this is the organization which were involved in development of the whole process and how we can use the water to grow microalgae, and once microalgae is produced, how best you can use directly into the product. One application is to use the whole microalgae directly onto the product side of it. Extensive amount of research activities has been carried out already how we produce microalgae. What is limiting is how best we can make use of the product, developing a product, solving your health issues, wellness issues, another one, and delivering as a source of protein. Some microalgal species can have a protein as high as 52% on a dry basis. It's quite significant. Yeah. So there you have to just recover the oil and then to have a protein. So there are a number of different areas what can be you can focus on. And in terms of mapping the wastewater and to recover the nutrient or to see the reduction of CO2, you can always measure how much CO2 a plant is consuming or how much CO2 a microalgae can consume over time. If I ask you a question, if how much of how to estimate CO2 consumption rate, how we can estimate how a plant can consume CO2. If suppose environment CO2 is there, or if you take industrial emission, you have a lot of CO2 coming out of it, yeah, of any process. How much CO2 it can consume? Suppose I was talking to one of your colleague yesterday, and we were discussing that if suppose there is CO2, take it as unit as a 2 liter of gas is there, yeah, and I have two options, plant A and plant B, yeah. It is grown in this particular environment. Which plant I should grow to capture maximum amount of CO2? How do we estimate that? We all know that banyan tree and peepal tree takes maximum CO2 and purifies the air. How this can be estimated? We all know that 6 CO2 plus 6 H2O, what it will produce? C6 H12O6 plus oxygen, yeah. What is this process called? Photosynthesis. And we all studied when we were in primary schools, yeah. Not this equation but the photosynthesis. But very same equation is even now it is valid. So only plant can produce a glucose, and this glucose goes into starch as a storage material, and starch what we consume to get energy back in a form of glucose, and we store it in a form of glycogen, yeah, right. So this is what the cycle, the way it works. So if you go back to the carbon cycle or nitrogen cycle, same way, coming back to the base question, if you have a tree A, that is how many of you like mango? All. Which one? The Dashehri. So take it as Dashehri. When I don't know how to write a spelling, I just make it like this, you know. And other mango variety is suppose Totapari, yeah, or Alfonso, yeah. Alfonso is used for mainly most of those mango drink. So which tree will consume maximum amount of CO2 from environment? How do we know that? It's not rocket science question, it's not rocket science technique. So any of the carbon dioxide which is absorbed, same thing applies for seaweed. When you saw the seaweed was there on a rope, it starts growing. When it grows, it collects a biomass, yeah. So whatever biomass you have, is suppose biomass growth is 4 grams per day. Yeah. That means this 4 gram will have, you get an elemental analysis of carbon, hydrogen, oxygen, nitrogen, all this. So based on this, carbon is coming from where? Only from CO2. Yeah. Based on that, you can determine how much CO2 it can absorb. Yeah. So that way you can develop what type of biomass should be used to recover that nutrient. Same way, if you measure the biomass, and if suppose, coming back to microalgae, if microalgae is growing like this at this particular rate, at what point we should stop harvesting, or at what point you think is a maximum growth? You have to determine that, right? So once you grow this biomass, you follow an equation, rate of biomass, that is per uh, grams per day, and when it peaks up, and if you have a measured amount of biomass it is producing, based on that you can say the CO2 absorption, and similar pattern, how much nitrate and nitrites are there in the water, yeah, and that is recovered or converted in a form of protein. Yeah, these are the two ways you can see how we can develop the production rate or extraction of nutrients from water and conversion into the form of proteins. Yeah. So this is the way we can establish the wastewater valorization. Yeah. So that's one way of measuring that. Another application of these biomasses is to recovery of heavy metals. If you grow some of those plants, those heavy metals are recovered into the plant. That is another way of recovering those nutrients. It is very, very similar to the estimation of BOD and COD. Yeah. So here BOD and COD you are measuring based on amount of oxygen it requires to oxidize the organic matter, but there is a chemical equation related to that. Very same case when you are trying to measure the BOD COD in a form of growing microalgae or by growing seaweeds. Yeah. So this is what I was trying to cover on briefly about macroalgae, microalgae, and how these two are related to the wastewater. Now, what are the boundaries for the food waste? A general boundary, what we consider as a food waste, or how do we define a food waste? So what is the difference between food loss or food waste? Very quick definition. The food loss which is happening all along, which can be used for food consumption. We saw yesterday all the statistics, how much it implies and what all it does. Whereas food waste is towards the end of consumer. So if you'll see pre-harvest losses, mature and unharvested left in a field, and then you have to go for a processing, yeah, processing losses, distribution and retail losses, and then consumption, that is again from household or for domestic level. So this is the way we can estimate the food losses along a chain. Yeah. So what is definition? This is definition coming which is adopted in Europe through Fusion. This was a large project, that is food waste all the way after the pre-harvesting all the way to consumer and household. Yeah. A. Other one is European Commission defines the food waste from the transportation side all the way to household. These are the boundary conditions for different definitions. That is also one of the reason we can change our statistics based on what we consider as a food waste or a food loss. Yeah. You just change the like suppose if you change a definition of food loss or food waste, then the values are changed. Yeah. This is also one of the phenomena. So what is the definition to be used for food loss or food waste? You can define food waste in one way, and you can define food waste in another way, but what is the universally accepted definition? We all know what is 1 meter. What is a 1 meter? No, that is correct. So 100 centimeter, very good. And then 1 centimeter is on a ruler, right? But if that ruler is in Kashmir, where the temperature is low, will have a metal contraction. Same 1 meter if it is in Middle East or near equator, the 1 meter will have linear expansion. Yeah. So what is exactly calibrated 1 meter? Same thing happens with the weight, 1 kg. Yeah. It's if somebody's weight is 80 kg, is not heavy, but he's on a wrong planet. If he goes on moon, weight will be different. Yeah. So there's a mass and a weight. Same way the length of a stuff. The important part is how do we define it. So before we say food losses are along agri-food chain is 30%, then you have to define where you calculate a food waste. The reason why I'm saying this one is in the seafood sector, in some cases there is zero food loss because fish is harvested, washed, goes to the domestic one. So there is always everything related to food waste at the consumer end. Do you agree? Yeah. Whereas if the fish is processed commercially to produce a fillet, then you have a food loss plus food waste. In the processed product, food waste is less, whereas in processed product, food loss is there and food waste is there, whereas when it comes to whole fish consumption, only food waste is there. Did you get my point? Yeah. So how do we define that? So if you take United Nations Sustainability Developmental Goals again, all those 17 different goals. So this is the way food waste and food loss is defined in relation to Sustainability Developmental Goal number 12. Number 12 is related to what? Responsible consumption and production. So you have pre-harvest activity. So when it comes to pre-harvest activity, what are those related to seafood? Aquaculture or harvesting? Yeah. So you don't have any of those pre-harvest activities when it comes to seafood. These activities are applicable for terrestrial or land-based crops like pulses and cereals and other grains. And then you have harvesting. This is quite common in every agri-food operations. Then you have on-farm operation in terms of fish. What is it? Seafood, what it will be? That is your washing, cleaning and keeping it in freezing condition, right? Yeah. And then you have a transportation, storage and distribution, processing and packaging before freezing or live material, live biomass. Now, when it comes to fish, what could be the food losses along a chain, seafood? Whether it's an aquaculture or any other thing, what could be the food losses along the chain from harvesting till this point before retail? So you just think, you imagine a situation, you go get 10 kg of fish from the sea, yeah, you wash it, you pack it. When you get 10 kg of fish, so what could be the losses before you freeze it or thaw it? Because this is the topic what we are going to be, this lecture and the next one, more it will be, there is no fundamental principles behind. There are fundamental principles are there. Application of those all depends upon majority in the sense, in a form of common sense. Yeah, there cannot be that you can valorize a waste in a specific manner. We all have a different eating habit. We all have different product development strategies. So based on that, waste generates. So what could be the waste on the fish? Again, I'm not talking about the retail or consumption.
Fin will be there, fish fin.
I'm talking about whole fish. That is processing side of it, right? Yeah, correct. Fins, scales and all those are the waste. I'm talking about the whole fish. What could be the waste? You go, you throw a net, you go with a big boat in a sea, throws a net, you harvest a fish, yeah, or even aquaculture fish is harvested. So what could be the waste there? A is damaged fish, correct? B is spoiled or half killed fish, yeah, or whatever damage is there, or diseased fish, yeah, correct? It can have a disease. And C,
Inedible
hmm,
fishes, like
that
inedible.
is bycatches, yeah, right? That means smaller fish or larger fish which are picked along with it. When it comes to mussels or shellfish, it could be a damaged shells, because some shells are bought directly as a whole, yeah, diseased or damaged. That means you use a visual inspection to segregate it. So how you can avoid that one is what will be the valorization strategies for those. So that type of species can go for fertilizer or for different application. It's very similar if you harvest apples. All apples which are sound, that can go as a table apple, which are having a bruises and all, that can go for jam production or jellies production or making for juice production strategy. Similar thing applies for seafood also. There is only the drawing the parallels from the other processing streams. Now, when it comes to food waste, what it could be again for the food waste? So processing and packaging we will be covering in subsequent sections, like all you get fins, guts, viscera, and some cases in order to digest or to break the microalgae or macroalgae species from enzyme, you can always recover the enzyme from the gut of fish, because they have those enzymes which eats seaweeds, yeah, as well as microalgae which is grown in the water. So how best you can use that particular enzyme extraction from the fish viscera to use it as an enzymatic processes, yeah, that's one easy way of doing it. And all these damaged, spoiled, diseased fish or bycatches, where you can use this? What could be the application? Fertilizer already discussed, feed already discussed to some extent, yeah. What could be another application? BAIT, yeah, correct. So you can use those fish to attract other fish to catch it into your net or other specific one, yeah. So it's not somewhere it has been investigated, research is done. It is just you thought, oh, it will be good to use it as a bait, rather than using a whole fish as a baiting purpose, yeah. So that's that's one. So when it comes to sustainability developmental goal, 12.3.1 is considered from harvesting till processing and packaging. 12.3.2 is from when it is processed, that is at retail and consumption level, yeah. So whenever you are defining waste or valorizing waste, it is very important to establish a boundary, yeah. Otherwise it becomes meaningless. You may estimate a waste in a specific quantity, and another colleague of yours will say, in my process I have less amount of waste, just because where you are drawing the boundaries, yeah. So when it comes to these type of waste, if you are able to address those different type of waste or losses, we will be able to address clearly number of different United Nations developmental goals, yeah. So how we can reduce food losses or food waste? What will be the strategy? How we can reduce our food losses during the transportation? Cold chain is one of the most common answer everywhere it has been seen, yeah, and is common for every biomass or every crop, yeah. What could be the alternative to the cold chain, yeah? So that is any solutions related to that? I know cold chain is there. Potatoes are there is always a cold chain required. Wheat is there, always cold chain is required. But what for? Think of the time when there were no refrigerators, how those were preserved. Yeah? Evaporative cooling, yeah? Or putting digging the soil and putting it over there, yeah? These are the traditional methods. Are there any other technique you can preserve those type of element? Yeah? So this is all the thinking process. Sometimes we learn a lot from our history or from class 1 preservation, which can be now slightly optimized or can be advanced. So if we are able to manage food loss and waste, that is no poverty, zero hunger, good health and well-being, and affordable and clean energy, responsible production and consumption, climate action, life on land. Yeah, this is applicable also for your seafood, or is it only applicable for seafood? Because once it is in the water, you have taken it out, then you are talking about land. So all nutraceutical storage and other. So all these are the ways you can draw out your waste strategy or what could be the advantages. Yeah. So as you can see, this is all some of the knowledge and whatever been talking based on the experience working with different industry partners, working a lot with masters and undergrad students who come in for a placement. They come up with lot of different new ideas, which we nurture it and come up with the process. Yeah. It's not that all the scientific knowledge and everything, whatever your supervisors or lecturer is telling, they know everything. No. Yeah. That's the way it builds up the knowledge bank and we progress further. Yeah. So food losses and side stream when it comes to edible aquatic product. So here this is a broad one calculated and obtained from a specific region. So wild capture, as you can see, this is a boat, have a bit net, so you get everything collected. Your jellyfish, sponge, you went for a fish, you buy everything. Something like you throw a net, that means you enter into a supermarket, you went in to buy a specific product, but you came with 5 shopping bags. Yeah. So this is one. On land processing, that means how you're processing it or segregating it or removing whatever you don't need. That's on land. Retail, food services, that is HORAC is hospitality and restaurant and catering businesses. Yeah, because everything doesn't go to the straight to household. There are a lot of consumption are also done in food restaurants, catering businesses, or there is a party they need 200 kg of mussels. So all those element comes under food services, and then you have a household consumption. So you can see where all we have losses along the chain. Yeah. So that means approximately this many tons. So these are some of the global figures, but everything, whatever is there goes to bin, which is again not advisable because we are losing good resources into the bin, whether it goes for landfill or goes for incineration. Yeah. So what are the approaches, how we can reduce or quantify the waste and food losses, or what are the strategy? Yeah, only 2 strategies, simple. Reduce your food waste and food losses, or transform that food losses and food waste. Correct? It's very simple, isn't it? But how can we reduce food losses? Reduction of food losses and food waste along, I keep forgetting this is a pen, you can rub it from the other side, along agri food chain. Yeah, or whatever waste is generated, so how that waste can be transformed. Any idea? Any other technique to reduce waste? So there could be 100 different ways of reducing waste, and and transforming the waste. Do you think any product which does not contain any waste? Because a lot of commercial companies, they claim their production process does not generate any waste. Is it possible? There is always avoidable waste, yeah, and unavoidable. You take any of the crop, there will be always the waste which can be avoided, or there is a product which you cannot avoid. There will be a waste generated. So how we can valorize unavoidable waste scenario? For example, the whole fish itself, you won't be eating the visceral organ, or you won't be eating this skin or shells. Same way, if you take a plant crop, wheat grain can be consumed with the bran or the whole meal flour for making chapatis and other product. You have refined wheat flour making breads and cookies and other thing. Hull and a straw. It is farmers, they know how to make use of it. Yeah. Same thing, if you have mussels, you have shells, where you can use those shells. The shells they have, I'm not talking about chitin, chitosan and all those high value ingredient peptides and everything. That is all at the research level, or it's a specialized sectors are required for that. Good scientific knowledge is required, which you guys have. Think of the farmer, how he can use those shells. Crush those shells, use it as a source of calcium, or to use it for making your, along with the cement and all, to make houses. If you go on the coastal areas, especially near about Rameshwaram and other places, you will see how best uses are done. Even those shells which are cleaned, and people they keep it in their house as a decoration, or making all those curtains and other things. Yeah. So these are also some of the application how it can be used. Traditionally, in even in Uttar Pradesh, all those shells were used to peel potatoes. How many of you have seen it? Yeah. My mother used to use those shells to peel the potatoes. Like, you know, use peeling potatoes, you cut in between and use it for peeling. So there are different applications are there. So all these things are quite useful. Nowadays, for the sake of being in a natural way, we can reduce or valorize that waste. Yeah. So in this case, you have to have 3 or 4 different people sit down together and see what are the waste generated and how you can make use of those waste streams. Yeah. So since we all are scientists, or we all are studying science, so we always try to come up with a complicated solutions. Yeah. So how we can reduce, that is, the main focus is to improving the microbial safety, yeah, and processing efficiency. Yeah. So when it comes to microbial safety, that means how we can reduce the energy and water usage. You mentioned about the freezing chain. I'm just picking that particular point, and that requires huge amount of energy. Or for washing, how we can avoid usage of water to wash those side streams, or wash the whole biomass or side stream, and how we can reduce waste, and how we can create a new applications. Yeah, that is all comes under reduction strategy. I'm trying to simplify as much as I can. Yeah, and this is quite simple. You want to reduce a waste? What is the strategy? Why you want to reduce a waste, or how we can do it? A, by ensuring a microbial safety. If you are safe, then only you are talking about the quantity and the quality and other attributes, and improving process efficiency. So energy and water reduction, waste, and creating new application of those streams so that you can reduce the wastage. Whether it is, I will be using interchangeably both food losses and food waste. Yeah. Now, how many of you have heard about new technologies? Now, this is basically all the technologies which can be used for advanced processing. as an alternative thermal processing. Yeah, don't get shocked with seeing all this high pressure, pulse electric field, ultrasound, cold plasma, lipid oxidation, proteolysis, oxidation. Yeah, we will be going back to these technologies again when we go for transformational strategies, right? What it shows about high pressure, many of you are or from undergrad, masters and a PhD. High pressure processing is very similar to pressure cooking. Yeah. Only difference is pressure used is of more than 200 to 600 megapascals, and some places you will see 800, 900 megapascals. But commercially, anything more than 600 megapascals is quite challenging because of strength of material and requirement. Yeah. So these are known as non-thermal technologies. Why we call it non-thermal?
So using low temperature technology.
Correct. But low temperature, yeah, you all said about low temperature, right? But you know microorganisms can only be killed at 70 degree or 72 degrees Celsius. Yeah. Water boils at what temperature?
100 degree.
Can water boil at 90 degrees Celsius?
Yes. High.
Correct. If you go on mountain. Why I quoted this one? Because this is what we studied in our school. Yeah. When you go on a mountain, water boils at lower temperature. Yeah. So that means pressure is higher. Yeah. But if I reduce the pressure, yeah, or sorry, if I increase the pressure, temperature will boil at lower pressure. Yeah. If you know PV is equal to nRT. P is pressure, V is voltage. Good. Yeah, all are awake. That's nice. N is your mole, R is universal gas constant, T is temperature. Yeah. So the water which boils at 100 degrees Celsius is normal atmospheric pressure, that is 1 bar. Yeah. If you increase the pressure to 5000 bar, what will happen? Same thermal effect is observed at sublethal temperature. That's the only definition of non-thermal technologies. Yeah. Achieving microbial safety at sublethal temperature is non-thermal. Yeah. Because temperature is always increasing. Yeah. Temperature will get those application. Same thing, ultrasound. Your friend here is working on thermosonication using ultrasonic cavitation. Cold plasma you have already seen. Yeah. You all saw the cold plasma, right? Yeah. What way cold plasma works? Because you have seen the practical other day. That's the reason I'm asking you. Do the guess, whatever you learned from there, that's fine.
Sir, the cold plasma is working to the high voltage is applied in closed chamber. The fourth stage of matter is like glow, like matter is produced. That glow is create the radicals, free radicals in the food. Like due to the presence of moisture in food, the glow is produce the free radicals in the food, so it is toxic to the microorganism. It only used for a surface treatment for the foods.
Okay, that's correct, and I'll make it very simple because I always like to know things in a very, very base language. Yeah, plasma is a fourth state of matter. Yeah, if you have a solid, if you heat, what will happen? It converts into liquid. Yeah. If you further heat it, it becomes what? Gas. Yeah. And if you further breaks the gas, what it will form? Ions. Yeah. So that means O2, if it is broken down, it will form O minus. Yeah. These are all free radicals, right? And these are free radical, so they are ready to attack anything because everybody want to get stable. Yeah. It's same as with us. You want to study and then you want to get what is the common word used when you are going to settle in a life. Yeah. Everybody need to get settled. It takes time for different radical. So when this is a free radical, it will try to stabilize. Their transient time is very small. Yeah. So they will look for oxidizing the organic matter or whatever comes on their way. Yeah. And this, to create this free radical, you need very high voltage. That's one. Or very high temperature. Yeah. Either you need very high temperature or you need high voltage. So voltage can be in the tune of, suppose, 100 kVA. Yeah. But do you think if you use 100 kVA or 10 kVA or 12 kVA, what will happen to human being? But at the same time, plasma is also used for cancer research. We do a lot of work on plasma for targeted delivery for to create holes on a tumor through by plasma, so that we can deliver a targeted drugs. So can you explain, if you are talking about such a high voltage to create a plasma, even 10 kVA is okay for making plasma. Such a 10 kilovolt voltage, and you are generating it from 220 volt, what you are getting it, right? There is no substation in that plasma system. So still you are not getting electric shock. Remember, it's not the voltage which is important. Important is the current. Yeah. So if voltage is 12 volt and 5 amps, if we increase the voltage to 12,000 ampere, becomes 0.1 amps or so. So you won't get an electric shock, but this voltage is helpful in creating those species. Yeah. So those free radical which are created, they cause mainly oxidation. Yeah. So one of the key inactivation mechanism for microorganism is by oxidation. Same thing happens with the chlorine. When we keep saying that chlorine is used for inactivation, how chlorine works? To generate a chlorine one, we use sodium hypochlorite. Yeah. That is NaOCl. Yeah. This is the one nascent oxygen which causes microbial inactivation. Make sense? Yeah. So everywhere, if you know the mechanism, then you can deploy that. Yeah. That's why whenever free radical is formed, you have a water, it forms acidic solution. Yeah. Intentionally, I did not put a slide which talks about different technology and microbial inactivation. Yeah. So when we go for the further different technologies, there you will see how these technologies can inactivate microorganisms, and then you can relate this chemistry with microbial one. Yeah. So high pressure, that is by rupturing. Yeah. Because of pressure, it ruptures the cell. Ultrasonic, it forms, what is cavitation? Yeah, good. Yeah.
So that ultrasound creates a cavitation in the form of pressure difference, like rarefaction and the compression. By this difference, the microbial inactivation has been done, sir.
Okay. So how ultrasonic works basically, it forms compression, rarefaction and all. Somebody is asking you, please do the work. You won't listen. Somebody increase the frequency. Do the work. You start doing it. Yeah. That's the way sound works. Yeah. The simple way. Ultrasonic, when it passes through water, it forms cavities. Yeah. These cavities are cavitating bubbles. Either they explode or they implode. Yeah. That is cavitation formed because of sound pressure. Yeah. But you can also create a cavities based on water. If you turn on a tap, you see the water coming out very easily. Yeah. If you increase the speed of the water and the outlet of the water is the same diameter tap, it creates a lot of bubbles. Yeah. These are cavities. They break due to their internal pressure, that is implode or explode. During that process, it also breaks the water into their free radicals. Yeah. And this creates sonoporation on microorganisms or also causes breakdown of different molecules. Yeah. So that is the application, and that cavity formation depends upon the frequency of ultrasound. Yeah. What is the frequency of ultrasonic system?
So 20 to 40 kilohertz. It may be changed
20
up
kilohertz.
to,
Yeah.
20 megahertz.
Hmm?
2 megahertz. So basically, in ultrasound bath, 20 to 40 kilohertz has been in usage, sir.
Okay. Now, when it comes to bath system or a probe system, anything, you need a piezoelectric transducer.
Transducer.
What is piezoelectricity? Electricity, when you press it, it forms electricity. Can you know the piezoelectric material which you all might have it?
Quartz.
Correct. So quartz is having an ability, when you press it, it distributes positive and negative, and that creates an electric current. So that's the way watch, they all have a quartz as a piezoelectric material. Same way, when you give an electric current, those charges, they generate a pressure. Yeah. That's the principle used for ultrasonic probes. Yeah. Now, when it comes to ultrasound, the frequency range anything about 20 kilohertz, yeah, all the way to even 10 megahertz. Anything above 5 megahertz is used mainly for diagnostic purpose, car sensors and everything, and processing zone between 20 to close to 1 megahertz depending upon the application. When we'll go through the technology, I'll show you number of different types of system. What you have seen is what is commercially most prominently available. But there are 400 kilohertz, 600 kilohertz, and there is no relationship between what is best at 20 kilohertz may not work at 100 kilohertz, what works at 100 kilohertz may not work at 20 kilohertz. Yeah. So it's always cause and effects. That's why ultrasound itself is an area of intense research. And then you have a pulse electric field. Here also we are talking about high amount of voltage. Yeah. But along with the frequency of the current and frequency as well as on the current. So this causes electroporation, that means giving electric shock. So what happens, these are known for improving the microbial safety, but they do cause changes in protein and lipids, mainly oxidation and what? Oxidation. Protein gets oxidation and lipids get oxidized. Yeah. You would have seen, heard a term called protein denaturation happens. Yeah. But do you think protein denaturation is good or a bad?
For improvement of texture and all, this protein denaturation will be like in a positive manner, and in terms of nutrition, it is a negative impact.
Okay. So what is basically a denaturation?
Change of structure in the proteins.
Correct. Then what type of structure? They have 4 different stages structure, right?
Primary, secondary, tertiary.
We'll start with the bigger one. Quaternary structure, tertiary
Tertiary.
structure,
Secondary, primary.
secondary structure and
Primary.
primary structure. So what is the primary structure is? Sequence of amino acids. Yeah. So in body we need to break a primary structure in order to absorb amino acids. Yeah. And this amino acid attached with the peptide bond like a rope. Yeah. And then this rope are staked on different layers. Yeah. That is your secondary structure. Yeah. And those different ropes are structured into a coil form or different way. Then it becomes a tertiary structure. I'm not going to go into primary structure, like into the protein chemistry and all. And this tertiary structure, when it is joined together, makes a quaternary structure. So even if you shake a mill, you get denaturation. Yeah. And we have to denature to improve your digestibility, bioavailability and everything. Correct? Raw wheat flour, if you consume, you're done with the stomach upset. If you roast it, you make it panjiri or you make a laddu. Yeah. So you get a different flavor. So denaturation is important. But if you are looking for a specific application for gel, hydrogel, aerating gel or gluten network, there you don't need denaturation. Yeah. So commonly saying denaturation is not good is not a correct statement. Yeah, depends upon where do we need it. So in these proteins and lipid, all these things, they do have impact of all the technologies. How this impact can be changed depending upon the condition we need it to use. Cold plasma, that is one of the way where you can use plasma activated water. That means a free radical in a water having a fish in it can improve the shelf life on farm. Yeah, do you agree with that? So that's the way how you can deploy different techniques. So if you see here, second aspect is transformation. So we are not going into different technologies, how we can reduce the food waste along the processing by deploying different non-thermal technologies, thermal processing and all. If we go into that, we'll deviate ourselves into a completely different domain. Other one is biotransformation. That means whatever biomass we have, whether it's a waste, whether we can add value to it, or a whole biomass, we can convert into zero waste refineries. The example I was quoting only related to seaweed and microalgae because these are relatively new biomass. So let's do first thing right itself. That means design a process where you have every fraction is utilized. Yeah, because this concept was not there 20 years, 30 years ago when we started consuming fish or shells. We just was only interested in the grains, forget about it. You know, in northern state, the straw is having very good functions, but what we do to have a quick turnaround, we burn it in a field. Yeah, still you get some minerals and you want to get the next crop. But if you have a process to make the maximum value out of a straw, in summer straw is not available, in winter it is available. Yeah, the straws which is required for animal feed, that is not available in summer because all the animals, they are starving because they need something to eat. So if you preserve the straw over 3-4 months, you make value to it, and at the same time you solve the feeding problem for cattle. Yeah, and they require simple interventions. You don't need a rocket science technology to do that. Yeah. Okay, again bit of deviation when it comes to straw. How do we preserve bread? By using calcium propionate. Yeah, very same calcium propionate which avoids the mold and fungal growth. If it is added with the straw and packed, straw can be kept for 5 to 6 months. There are multiple companies who are making this type of medicated straw, which is also used for making animal bedding. And in some cases, that particular straw, what is added in is cow urine or any of those byproducts, so that animal won't eat that which is there used for their bedding purposes. Yeah. So these are the simple intervention which I have seen people doing it on a farm. Not only in Europe, even in India, they do have their own way, but that requires some bit of brushing up with the knowledge and technology and to make into a full-fledged process. Yeah. Now coming back to this biotransformation, again related to sustainability developmental goals. Here land under water comes in, climate action, responsible consumption, infrastructure and good health and well-being. So it is related to different sustainability developmental goals. So what are the transformational strategies? Yeah. So very same technologies, what you see here, which we discussed briefly about non-thermal technologies or new processing, new treatment technologies and novel extraction, which can be used for improving shelf life and safety. Yeah. Enhanced recovery. So if you use ultrasonics for preservation, you can also use ultrasonic for extraction purpose. Yeah, because it is disrupting a matrix. High pressure treatment will disrupt the biomass so that you can have better protein recovery or better nutrient recovery. And when you use all these new technologies, you have a better nutritional properties compared to conventional method as a thermal processing. You would have seen a lot in your lectures about non-thermal technology, so I'm not going to go into details of it. And I work mainly on range of different non-thermal technologies, and if you have any question related to that, pertinent to this particular module or any other, feel free to ask, yeah? And then once we are able to use this technology, either with the processing, pre-treatment or for extraction, we can add value and we can utilize waste, yeah? I can quote number of different technologies, number of different applications to valorize different processes. Now, this will take bit of time to digest, yeah? This is from a reference of 2020. If you want to know about the paper, I can. And this is pretty much clear. You can read it, yeah? This is a high resolution photograph. What it shows, what are the food waste, yeah, from different streams, and what are the potential pathways you can generate. How many of you have seen this publication? So you'll see this particular specific reference of publication in majority the report which are dealing with the food waste, food losses, valorization. So if you'll see fish-based product, these blue lines, if you track these blue lines, what all you can get? Fatty acids, yeah? Enzymes, minerals, yeah? And then cereals, see this line, yeah? Okay, that's the way to read it. Half is your food waste and half is our different pathway, and all these ones are different application, whether to use it agriculture, pharmaceutical, medical sector, food industry, biomaterial, textiles, pulp and paper, environmental sector and chemical industry, yeah? Make sense? So you can make this particular diagram. These are potential application, how this can be valorized for different pathways, yeah? So this is all your fish. Is there any crop which is missing from here? You have seafood, you have dairy, cereals, fruits, meat, oilseed, sugar, starchy crop, vegetables. Anything else which is missing? I know there is something missing there. Somewhat it is related in seafood, partially missing. This is partially missing, and completely missing is seaweed, yeah, and microalgae, yeah. So majority of the focus I'll try to shift it on the plant side of it, yeah, because that information is limited in the literature, and rest all valorization strategies you can easily find into different literature. So with this thought, what we are quantifying, we need to quantify all the waste, whatever is coming in, and how we can valorize it for different application in human food or feed applications, yeah. So basically what we are trying to cover was to do with the biorefinery approach, yeah, so that we can make use of all the application. And in order to do that, we need to quantify the waste, yeah, and how we can reduce or transform the waste, yeah. Okay. So in next lecture, we'll be covering bit on the quantification of waste and streams, and going back how we can reduce it at a consumer level or at retail or at a processing level, yeah. So remember the definition of food loss and food waste, they both comes in umbrella of UN SDG number 12, that is responsible production and consumption, yeah.